My name is Matthew Walsh. This is my repeat CA for data structures for games, CA2 doubly linked list. So we're going to start off in the player.cpp. So including player.h, iostream using standard namespace. Got a default constructor for the player class, getters, and setters for each variable. In the player.h, private variables set and the public methods and default constructor. Okay. The wlinked_list.h is a modification of the singly linked list. Let's see. The class contains data, a node to the, or a pointer to the next node, and a pointer to the previous node. Has a default constructor for each node, or for each pointer. And we got the insert after. Creates a new node. Takes the passed in data and sets it to the data currently in the new node. Makes then the new node points to the next node, and the previous node points to the new node. Now we got the list itself with the head and tail and a default constructor. Head, tail, and count set to 0 creates an empty list. The destructor removes or deletes the dynamically allocated memory, creates an iterator from the head and sets next equal to 0. While the iter is not equal to 0, it sets the pointer to the next node and deletes the current node. And then iter points to the next node. Append to add data onto the end of the list. Check if the list is empty. Otherwise, mhead is equal to mtail, and then it is used from a new data type, or is equal to a new data type, and the data passed in is set to the data in the node. Then the tail points to the insert after method and the data being passed in, and the count is increased. Prepend adds the data to the start of the list by creating a new node, setting the current data, the data in the node equal to the new passed in data, and the pointer that points to the next node is set to the head. Set the head node and tail node if it is necessary to do so. If the tail is currently set to 0, set the tail equal to the head and increase the count. Remove head removes the first element from the list. Its complexity is O. This sets the head on a node to 0 and then deletes that head. If the head is already equal to 0, set the tail equal to 0 and decrease the count. To remove the tail, sets the pointer to the previous node set to 0, the node mhead. If it's not equal to 0, then delete the head. Have the head equal the tail, which will both be set to 0. Skip ahead and find the node right before the last node. That the node that points to the next node is not equal to the node that points to the previous. Set the node pointing to the next node. Then we got iterators, insert functions, which are all commented in explained is that if the iterator does not belong to the list, then do nothing. If pIterator.mList is not equal to a list in that iterator, then return out. So the insert function inserts the value after the node, or after the previous node, and then the tail is then updated to point to the new node. Otherwise, just append the data. A remove function, which removes a set item from the list. As before in the append or in the insert function, if the iterator does not belong, then return. If the node is not valid, return. This moves the iterator forward, pIterator.forth, and then remove the head. Let's see. If the node we're deleting is the tail, then update the tail by setting mtail equal to node, which is the pointer to the next value. Then delete that node, or delete the node points to the next node, and relink the two nodes. Then we have the standard stuff, which came from the single linked list as well, which was the start setting the mlist point that points to the head and the node. Iter.forth setting forward the node and the pointer to the next node, essentially moving the pointer forward. Dot item will get the item that the iterator points to, the data, and checking whether the iterator is valid, making sure that it's returning that the iterator is not null. We go to the main app. We're including the wlinked list, player, iostream, windows.h, and namespace. Here we have all the declared methods that are contained in the wlinked list.h function. When we go into the main, we create a new list, a new iterator, and a player. Here we have the menu system. While the choice is not equal to 9, we have an insert, delete, print, search, average experience, remove duplicates, and quit. There's the option to add an item at the start of the list, the end of the list, and a chosen position, and different options, prepend, append. And here, create the player, get the iterator, set the iterator to the start, get the index of where you want to insert the new item, and start a loop. Move the iterator forward, iter.forth, by how many times the index, or to what position you want it to be inserted at, which is the index in the list, and search the iterator and player. Let's see. Removing items. We're doing the same thing here, where the position of the item that you want to remove, then it's iter.forth, getting to the position, and remove that iterator. Choice 3 prints the list. Choice 4 gives you the option to search by name, level, and experience. If option is equal to 1, you enter the player's name, and it searches the list. When you want to search by a level, you can search by level or range of levels. This will get you search level, the list and the level you're searching on, or the low level, high level, and search level range. Option 3, you can search by experience, take in the experience, and then search for it. Choice 5 is searching by level. Again, take in level. Oh, this is the average experience. You need to take in the level, and it will generate the average experience points based on all members at that level. Remove duplicates, else it's an invalid option unless the choice is equal to 9, which closes it. Print list, standard for loop, iter.item, getting all the member variables and printing them out for each one. Creating a player, creates a new player. enter their names, set their name, set their last name. All players will start at default level 1 with experience 10. The average experience points, we have the double for average experience, int for current experience, and int for the count. Create an iterator, and then we have a standard for loop. If that iterator.item, if that item available's level is equal to the level being passed in, then get their experience, which is equal to int a, experience is equal to experience plus a, and increase the count. If the count came back equal to 0, then there are no players on that level. Otherwise, the average experience is the experience divided by the count, and output the average experience. The remove duplicate function currently does not work to its full potential. It will, however, remove one single copy of a value. If creates two iterators and then iterates through the loop, checking whether iterator 1 and iterator 2's name and last names match. This can cause problems though, because it will, if they're too close together, it will find itself and try to remove itself twice, which causes an error. Here we have the search function. Lets you search by name. Going through, let's see, creates an iterator, creates a new array, an account, standard for loop. If the item's name is equal to the search name, append it to this new array and increase the count. Count's equal to 0, no matches were found. Then print the new array. Same thing for search level is our standard for loop. If the level is equal to the passed in level, place into this new array here. Otherwise, no match found if the count is 0. Search level range. This is done by passing in a low value and a high value. Set the count equal to 0, an array to store all of the results in, and an iterator. For loop through the level. If the level is greater or equal to low, and the iterator's level is less than or equal to the high, append it. If the count is 0, no match is found. Otherwise, print the search list. Search experience, array to store the values. If the experience is equal to the passed in amount of experience, add it and print it, or no match was found. Thank you for watching.